All right, it's my own ID. Manage participants. And chat. And Chris, Adrian. What's that? No.
Joe, are you there? Hello?
All right, give me 10 seconds. All right, sorry about that. All right, Mary, you got a question for me?
Me? Yeah, I do. So, can you hear me?
I can.
Okay, so my question was in regards to, we had said that for an object to do work on a system, it had to be outside of the system, but then when I
No. So it's only external forces doing work on a system that change the energy of the system.
Okay.
Meaning a force, if I have 5 objects that are part of a system, those objects can do work on each other. That would be internal work that doesn't change the overall total energy of the system. It might convert one form of energy to another, but the total energy of the system is only affected by work done on the system by things outside the system.
Okay.
And this all still, it's kind of, chapter 10 is when we're going to start looking more at conservation of energy. I'm going to start to move a little bit faster, but I wanted to spend a bunch of time just setting up the basic energy model and then doing some of this beginning setup stuff. Adrian or Chris or Tim, do you have a question? Or was there another question, Mary?
Well, if someone else has a question, they can ask. I was just going to ask you about the PLC a little bit.
Okay. Does anybody have any homework questions or questions on the lecture before I do a PLC question? Adrian?
Mine was about the first PLC number 9 as well, so there is some. I would like to hear that as well.
Okay, let me.
Which PLC are we supposed to be doing this week? It was.
PLC 9 is this week, but you're going to turn in PLCs 8 and 9 together.
Okay.
So
can I just turn it in whenever I get it done, or?
Yeah, I mean, those dates are just the very last dates that they can be turned in by. So it is not, don't wait until the last minute. So let me open
a little late for that, but okay.
Okay, we want Fizzlets, open a new tab for a PLC activities, work in kinetic energy, open in a new tab. Vertical, blah, 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 bam, 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 bam. Okay. Mary or Adrian, whoever, Chris, question on a PLC? Or Adrian, do you have a specific one? This is PLC number 9?
I cannot seem to find a foothold on 6.4. I'm entirely uncertain of how to go about it.
Hold on, let me pull this.
Agreed.
Same.
6.4. The bowling ball is lifted from rest onto a shelf by an external agent, starts from rest and ends at rest. for each quantity below, rank them from least to greatest. Okay, so let me share this. Everybody see my share?
Yeah.
Okay, and let me set problem 6.4. Mechanics, work, problem, open a new tab. Oh, excellent. Can you guys see this animation running?
Yeah.
Okay. So one of the things I'm going to get to towards the, well, I guess at the end of Tuesday, is that there are different kinds of forces that we generally classify as conservative or non-conservative forces. And I'll talk on this on Tuesday, but gravity is a conservative force, which means that the work done by gravity is path independent. What that means is if I were to take a ball, like in this case, the ball starts at this point and ends at this point. It doesn't matter if you lift the object straight from that elevation to the final one, or if you do some sort of curved, long about path, as long as you start and stop at the same spot. The work done by a conservative force is the same. So if I lift a ball up and it starts here and ends here and I lift it straight up, I do the same amount of work as if I start here, go over here, go up, go around, go down, blah, 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 and then end here. As long as I start and stop at the same spot, the total work done is 0. So in this case, all 3 animations, or 4 animations, it's always starting and stopping at the exact same spot. And so the work done by gravity is the same in all 4 cases.
Even in animation 3 where it goes higher than the ending spot, like it actually, it moves like a projectile really, but.
So here's a question then, thinking about this. So I kind of went through the fact that the work, whether it's positive, negative, or 0, only depends upon the angle between the force and the displacement. So as you lift something up, is gravity doing positive work or negative work on the object? What do you think?
Positive.
Would that be negative work?
Negative.
It would be negative because if I'm lifting something up, let me get back to
It's in the opposite direction.
Yeah, so if I'm lifting something straight up, then my displacement, let's call it delta y, would be straight up, but the force of gravity, mg, always acts straight down, which means when I go to calculate the work done, the angle I would use would be 180 degrees. So anytime something changes in elevation and increases its elevation, gravity does negative work. Anytime something decreases in elevation, gravity does positive work. So let me clear all drawings for a second. So if I were to just lift something from here to here, gravity is doing negative work the entire time. But let's say instead I lifted it from here to here, and then over sideways, and then down, and then got back over here. What I would see is gravity is doing more negative work in this case, but when it's going down, gravity is doing positive work. And when I'm moving sideways, the angle between the force and the displacement would be 90 degrees. So what I would get is if I add the work done here, plus the work done here, plus the work done here, plus the work done here, I get the exact same answer as if I just went straight up.
Mm-hmm.
And that's only true, though, for a type of force called a conservative force. And I'll make it easy for you. You're only going to see 2 conservative forces in Physics 4a and a couple in Physics 4b. So gravity and elastic force are the only forces that are conservative. and those are the only forces we can have a potential energy function for.
Are we gonna have four?
So the second part of this question was, let me stop this for a second. Or wait, no, I want to, let me just move this. Mouse. So the work done by the external agent. Clear all. Why can't I clear up more? Clear all drawings. So one of the other things we're going to get to is the work done. I need to annotate again. The total work done by all external forces is going to equal the change in kinetic energy of the system. In this particular clicker question, we only have two external forces acting. We have the work done by gravity, and let's say the work done by the hand. And that has to equal the change in kinetic energy. Well, this ball started from rest and it ended from rest, which means the change in kinetic energy is 0, which means that however much work gravity did, the hand did the exact opposite amount of work. So if gravity did the exact same amount of work in all 4 cases, that means the external agent, or the hand, did the exact same amount of work in all 4 cases also. Only instead of being negative, the total work done by the hand is positive, which means that the total work done on the bowling ball is going to equal 0. And I know that because the change in kinetic energy of the bowling ball is 0.
But it has more potential energy now, though, right?
Correct. Let me stop that. When did I say these PLCs were due? Tuesday, right?
Tuesday.
Okay.
Yeah. So when we look at the work done on the ball by the external agent or the hand, how do we deal with the fact that the hand is moving in 2 dimensions? So it's not just lifting up as it kind of looks in the picture, but it is also lifting in the X direction.
Right. So this is a case where I wouldn't try and, let me share this whiteboard again. I wouldn't try and do any kind of calculation. So like the ball started here, and let's say it ended at the top of the cliff. And I did one case, went up, down, over, so on and so forth. Well, just like looking at gravity, sometimes the hand is going to be doing positive work. Well, here's a question. When is the hand going to be doing positive work? And it's basically when the displacement and the force are in the same direction. So anytime the ball is moving upwards, the hand is doing positive work, but gravity is doing negative work. And so the easiest way to think about just dealing with the hand is looking at the fact that the work done by gravity is the same in all 4 cases. You don't know exactly what the value is. You're not given enough information. But the fact that they all start and end at the same height means the work done is going to be the same in all 4 cases. And I know that the work done by gravity plus the work done by this person is going to equal the change in kinetic energy, which is 0, because the object starts and ends at rest, which means that the work done by this external agent has to equal negative the work done by gravity. So if the work done by gravity was the same in all 4 cases, that also means the work done by the external agent or the hand is the same in all 4 cases also. Pause, stop that.
Right, so for the For the what do you call it? The lab reports, we're supposed to turn in the 2 that we should have turned in
Correct.
on Wednesday before the.
Yeah, so next Wednesday you're you're basically uploading labs 5, 6, and 7.
Okay, sounds good. Well, I'm gonna go get some food.
All right. Have a wonderful rest of your day.
Yeah, you too. I'll see you on Monday.
Yep.
So a quick question on this PLC 9. Are we going to be covering more of Chapter 9 on Monday and Tuesday, or?
Yes, and I'm going to give people hints on this PLC on Monday, just because, I mean, one, I want to remind people that, you know, the prerequisite for this class was, you know, high school physics or physics 11. So some of this stuff I'm expecting people hopefully will remember, that gravity is a conservative force, which means the work done is path independent. So I'm going to use some PLCs more as an introduction than I have before. Meaning I'm hoping that people have to do a little bit of research to get some of these PLC questions, just because I'm trying to keep people on top of everything and not waiting till the last minute. I don't know if I'll survive, or I don't know if that'll, we'll see how that works.
Yeah, okay.
Have you guys taken the quiz or turned in the homework yet?
Yeah.
How did that go?
Mellow.
Mellow? So, I mean, like turning in the homework using Mastering Physics is going okay?
Yeah, it was pretty straightforward as far as multiple choice goes and clicking your answers in. I think it's important for people to remember to check at the end, looking at all of the answers or the questions where they're listed. You can see a check mark next to the ones you've done. So just checking before you submit your assignment that you did actually click submit on each one.
Got it. Good. I'm hoping that
Otherwise,
I'm hoping that everything settles down, because yeah, there are a bunch of people that have issues setting up Mastering Physics, going to the wrong website. I have answered so many emails in the last few weeks.
Yeah, I mean, I don't know. It is, once you figure out that it's 3 different websites, as far as like 3 different links really, of how it works, and then turning pop-ups off on all of them, or pop-up blocking off on all of them, like it seemed to be fine from there.
Yeah, and yeah, I sent out another email this morning just because I kept getting the same emails. And yeah, it's weird. If you try and type it into the browser, it'll redirect you to this different site. And it took me a while to figure it out. And finally, I just kept, yeah. So if you don't click on the right thing, it takes you to a different site that I have no idea why it's not behaving the same, but it doesn't.
Yeah.
Apologies if this is unrelated, but I had an idea about the clicker questions. Do you see, we have these emotes here, like raise hand, yes, no. Do you see that as a vote tally, or just see something by the names?
I just see, I see something by the names. So it's not tallying who is participating or anything like that.
Unfortunate. I thought maybe they could be tallied up the same way. No,
yeah, I thought about that, and like I thought about whether or not I'd have class participation dependent upon, you know, coming to these Zoom lectures. But you know, I have my daughter half-time. I'm trying to work out homeschooling with her. Other people have the same issues, and so given this new paradigm, I don't think it's right to force people to have to be in front of the computer at a certain time, because everybody's life is crazy right now.
Yeah, absolutely.
But I might try and do the breakout rooms again, or maybe just put people in a breakout rooms to discuss how they would start a problem or something like that. I don't want it to be me just lecturing the entire time, but I don't know. I'm still figuring out the best way of doing all this.
if you want to practice with reactions or breakout rooms, we could do something like that in these office hours?
I did it before. What I realized is that when I put people into breakout rooms, all they can see is the breakout room. But yeah, even if I'm sharing something, they can't see it. And so the way, yeah, I don't know. I'm still thinking about it. But yeah, once I have a plan, I'll try and test it out during office hours at some point.
So I think like the main conceptual takeaway on most of the PLC, sorry, I went back to that, but is just that thinking of work being positive or negative depending on if it's in the same or opposite direction of the direction of motion.
Of the displacement, yes.
Okay.
So yeah, the
And
magnitude of the force is always positive. The magnitude of the displacement is always positive. It's just what is the angle between the force and the displacement. If the angle is between 0 and 90, that is positive work. That force is adding energy to the object or system. If the angle is 90 degrees, that force is doing no work. It's not adding or removing energy. And if the angle is between 90 and 180, that force is doing negative work. It's removing energy from the system.
And if the angles are not given to us, like in that first question, don't overthink it, just.
No, don't overthink it. That's actually good advice for most things.
True. Okay. And then if the angle is given to us, like in the 6.7 on the PLC, it says that there's a 60-degree angle. If we're moving in one direction, it's that 60-degree angle. But then if we moved with the same force pushing on an object, but just moved it backwards in the
Oh wait, so just so you know, that problem, reading it now, that gives you, let me pull it up actually, 6.7, and just share that. All right, share screen, Quizlet, share. All right, hit play. So that 60 degrees, push 60 degrees from the vertical. So one, that means, just to be clear, annotate. Generally, if they're talking about 60 degrees from the vertical, that means if I draw a line like this, the angle that that thing is making is 60 degrees. Right. So the box, though, the displacement, the box started, let me reset this. The box started here and ended here, so the displacement is to the right. Mm-hmm. So, you know, this box is, draw. So this box is being displaced to the right. So let me pull something up real quick. Example problem.
So we want the X part of the force?
Hold on one second. PLC activity, PLC 9, work energy, solutions. Oh, we're not even calculating. I'm sorry. I thought this was a lot more complicated. Stop share. Oh. So for that problem, you're not even calculating exact values. You're just calculating whether the work is positive, negative, or zero. Or in fact, you're not even calculating. You're just answering whether it's positive, negative, or zero.
Well, and my question wasn't so much about the question there, but more if, so when you're pushing that box, it has a 30-degree angle from the x-axis.
Correct.
And if you, and in that case, we were pushing it to the left, but if we had pulled the box back with the hand in the same angle, would we then use the opposite angle? So instead of using 30 degrees, we would look at it as 150 degrees?
So this is if the box started at the left and moved to the right, but the force was still at the, yes, you would use the 150. or 120 or whatever that ends up being.
Right.
And it kind of makes sense, right? If a force is acting in the same direction something's moving, that causes the speed to increase. That force is adding energy to the system. If the force is acting in the opposite direction something's moving, that's causing it to slow down, which is removing energy from the system. It's just sort of one way of thinking about it, right? If something's accelerating in the same direction it's moving, it's speeding up. So if the force is in the same direction something's already moving, speed is going to increase, kinetic energy is going to increase. If the acceleration's in the opposite direction of the velocity, the object's slowing down. So if the force is in the opposite direction something's moving, that force is going to cause that object to slow down. It's going to be removing kinetic energy from the system. It's going to be doing negative work.
Mhm. Thank you.
You are welcome. All right, I'm going to end this office hours, go get some food. Hope you guys have a wonderful weekend, and I'll see you on Monday, and I'll be around by email contact if you guys have any questions over the weekend.
Thanks, Joe.
All right, take care, guys.